Assalamu alaikum. Today my student will talk about chapter 14, which is about the basic elements and phasor. And we'll talk in this chapter, half of this chapter also about math, because we need this in our course, which is 14.6 rectangular form and 14.7 polar form and 14.8 conversion between these two forms. After that, we'll back to 14.2, 14.4, which are talking about the response of basic R, L, and C elements to a sinusoidal voltage or current. And 14.4 will introduce the average power and power factor. Just go to the book, chapter 14, page 643. We'll start to talk about complex number. If you remember in your course in math, talk about complex number. What is complex number? If you have any number has a real number and sorry, if you have any number have real axis and imaginary axis, okay, this will be a complex number. A complex number represent a point in a two-dimensional plane located with a reference of two distinct axes. Okay, this complex number we can write it in form of rectangular form. Okay, rectangular form, which is x plus jy. J, if you can say j or I. Okay, if you remember I, some book write I, x plus jy, this rectangular form. If we need to take an example, 14.3, we have a, b, c. We can show, for example, one of them. Here c equal 3 plus j4. 3 is the real number and j4 is the imaginary number. Here c equals 0 minus j6. You can write this number without writing 0, but here to show to you there is no real number, only imaginary number, which is minus j6. Last one, minus 10 minus j20. Let us show, let us see, for example, a 3 in the real number, 1 2 3 in real axis, and then you can go for imaginary. If it is not plus j4 minus j4, you can go down, and then you draw the resultant between them. Draw from the 0 until you reach the end point for this number of this vector. Okay, similar here, minus j direct without real number. Here minus 10 in the real axis, and then go minus 20 in the imaginary axis. We have another form of complex number, which is called polar form. Polar form, it's written z and theta. You can see here, if you draw a vector, this is called z, the magnitude here called z, and the angle from 0 to this vector called theta. If you write, if you find some polar form by minus z, for example minus 10 and the angle 25, you can rewrite it by z positive angle plus or minus 180. Okay, let us take يعني, example 13.14, 5 angle 13, similar, it is similar to what we studied in the lab. Okay, here the 5 and the angle from 0 to the vector 30. What about minus 4.2 angle 60? Since we have minus, we can say the vector is 4.2, the angle 60 plus 180 or minus 180, like here. Okay, they add 180, becomes 4.2, 240. You go from 0 to 180. Okay, or you can say y minus 60 minus 180, it become minus 120, similar. Okay, now in our course we need to convert from a rectangular form to polar form or the opposite. How to convert this number from rectangular form to polar and from polar to rectangular. Okay, z equal, if we need to write z and by theta by polar, z equal x square plus y square under the root here, similar to Pythagoras. Okay, we have x and y, we can square the x and square the y, and put it under the root, we will get the z. And how to get the theta? We can find by tan y over tan inverse y over x. Okay, tan inverse y over x. What about the opposite? If we have z and theta and we need to write by rectangular form, we can say x equal z cosine theta and y z sine theta. Here's some example how to convert. It is direct, you can try to solve. Here convert the following from rectangular to polar. We need to write by this form. Okay, apply by your calculator and then they draw. And here convert the from polar to rectangular. Okay, this part for mathematical, what we need from the math, and we will go to 14.2 now. Okay, 14.2 talk about the response of basic R, L and C elements to a sinusoidal voltage or current. If you remember, when we write current from last lecture, if you write current or voltage by small letter, this means we need to write this voltage by sinusoidal expression. V here equal Vm sine omega t. Okay, for the resistor. We'll study the resistor and inductor and then capacitor. We will see the response or the relation between the current and voltage if we apply in the resistor or inductor or capacitor. Okay, right. Here Vm over R, we can write it together. Okay, it will be considered as a constant, which is Im, and sine omega t similar. Okay, this means Im equal V over R, which is this. If we have Vm, we can direct find Im. Okay. So what about the opposite? If we have IR, we have I, and we need to find the V. Similar. Multiply I, which is Im sine omega t, multiply by R, which will be Im R constant. It will be Bm, the peak, the magnitude, the maximum, sine omega t. This means this is similar. This formula similar to this formula, similar to Ohm's law. Okay. We have this for this word. We need to be to understand this for a purely resistive element. The voltage across the current through the element are in phase. In phase. Okay. What does mean in phase? This means the voltage and current in the resistor will start from the same point. Okay. Here in this example, since there is no shift, they start from zero, both current and voltage. Okay. The magnitude difference since the current less than the voltage, but we need when we say in phase, we need to concentrate about the start. Okay, they start all in zero. But what about for example, if there is shift 20 or 30 in the resistor, the voltage will start from 20 or minus 20. Okay, and the current will start from minus 20. Okay. Some student consider in phase that start from zero. No, not this is not correct. Uh, if we say in phase, this means we start from zero. Okay, let us talk now about inductor. Okay, similar. We know that in electrical, if we need to find the voltage in the inductor, since it is there is variable in the current. Okay, we make the derivative for the current and to multiply by inductance L. Okay, we will find the voltage equation. Sorry. We know that IL, or it's given for example in this section, IL equal Im sine omega t. If we need to make the derivative for IL here, we will substitute here derivative for IL, Im sine omega t. Im it's constant, will go outside of the derivative, and sine omega t become omega cosine omega t. Since the variable is t and omega considered as constant, it become Lim omega cosine omega t. Okay, we know that from this last chapter, if we need to convert cosine, to sine, we need to add 90 degrees. Okay, like this. IL starts from zero. Now we found VL shifted by 90 degree. Since it is plus 90, this means minus 90. Then the voltage will start from minus. Okay. طيب. If you remember this voltage and this current, what can we say? Who is lead the other, or who is lagging the other? From last chapter, we talk what is the which curve reach the zero first. This means lead the other. Okay, here the voltage reach the zero, then the current reach the zero. This means voltage VL lead IL, or we can say the opposite. IL lag VL. Okay, this for pure inductive load. If we apply the voltage in the pure inductive load, for pure inductor, the voltage across the coil leads the current through coil by 90 degree. Okay. طيب. If we need to find the opposition or like a resistor, we need to divide the voltage over the current. Okay, here the voltage we have constant number omega LIM, which is this omega MIL, and for the current, if you remember here, the constant here, the peak only IM, divide by IM. IM cancel with IM, what's the remaining? Omega L. This the opposition for inductor. The quantity omega L called the reactance. Okay, from the word reaction of an inductor is symbolically represented by XL. Now, from now toward, we will say XL, and it's measured in ohm. Now we have resistor in ohm, we have XL by ohm, similar unit now. Okay, you can find XL by omega L or XL equal V over M. So you can see it's similar to Ohm's law. Inductive reactance is the opposition of the flow of the current. If you know, you need to know what is the inductive reactance. Is the opposition of the flow of the current. From this formula, you can write this formula: Im Vm over XL, or Vm equal Im Ohm's law. Ohm's law. You can say it's Ohm's law. What about the capacitor? We have voltage here on Vm sine omega t, and we need to find IC. Okay, similar to inductor, we have the formula IC equal capacitance multiplied by the derivative of the voltage. And we know that in this section, Vc equal Vm sine omega t. If we derive it, Vm will go outside, okay, and this becomes cosine omega t, omega sine omega t, and omega go outside with the constant, and we need to convert cosine to sine. It will be sine omega plus 90 from math. Okay, this is the peak now, and this is the shift. If we draw the voltage starts from 0 in this example, in this section now, and the current shifted by 90 degree. It is minus 90. This means starts from minus. Now we can say the current reached the 0 before the voltage reached the 0. This means the current lead the voltage, or the voltage VC lag IC. Here it's written here for a capacitor. IC leads VC by 90 degree, or VC lag IC by 90 degree. Okay, it is similar here. If we need to find the opposition, Vm peak over Im peak, Vm over omega C Vm, which is this. Can Vm cancel with Vm? It's remaining 1 over omega C. Now it's called here the quantity 1 over omega C called reactance of the capacitor, similar to reactance of the inductor. The symbol called XC. XC equal 1 over omega C by Ohm's law. ohms unit. Here it's similar. You can write XC Vm over Im, the peak ohms law, or Im Vm over XC, or Vm if you need it, Im multiplied by XC. Since we can find the voltage in the current in the inductor, the voltage in the inductor by the derivative of the current, it is the opposite. If we have the voltage, we can integrate it and find IL. Similar to the capacitor, since we can find the current in the capacitor by derivative of the voltage, we can find the voltage by integrate IC. Let's see some example. The voltage across a resistor, here say resistor, provided below. Find the sinusoidal expression for the current if the resistor 10 ohm. Sketch the curve for V and I. We have the voltage and we need to find the current. V equal 100 sine 377 t. 377 is the omega. We need to find current. First we need to find the peak, which is Vm over R. Vm here 100, you see, okay, and the resistor is 10. 100 over 10, 10 ampere. Okay, this is Im. And we know that the voltage and the current in phase in the resistor. This means I equal 10 sine 377 t. There is no shift. What about the part V? 25 sine 377 t plus 60. Similar. We will divide 25 by 10. It will become 2.5 current. And there is no shift here because in phase, resistor in phase, it will written similar. 2.5 sine 377 t plus 60. Okay, you can try to go other example 14.2. Okay, here example for the inductor 14.3. The current through 0.1 Henry, okay, which is L, this is L coil is provided. Find the sinusoidal expression for the voltage across the coil. Sketch the V and I curve. Okay, I equal 10 sine 377 t. You cannot divide. This is not XL. This is L, and we need to find XL by omega L. The formula omega L. Omega we have 377 and L 0.15. Now XL equal 37.7. Okay, if we have XL, we can multiply by the peak of the current and we will get the peak of the voltage, 377 volt. We can write it now. Voltage equal 377 peak sine 377 t, which is this omega is the peak. Don't confuse, it's different, but by luck this number same. Okay, now it's plus 90. See here, there is no plus or minus theta, but here plus 90 because the current lag the voltage in the inductor. Okay, the current starts from the 0 and the voltage from minus 90. Okay, for part B, if you go part B, 7 side 377 t minus 70, we will add 90 for this degree. Minus 70 plus 90, it will become plus 20. And for 7, this is the peak for the voltage. And we have XL, peak for the current, sorry. We have XL, multiply XL by the 7. You will get the peak for the voltage. See here, IM by IX by XL, 7 by 37.7, become 263. And the angle minus 70 plus 90, okay, because there is shift 90 degree between the current and voltage in the inductor, becomes plus 20. This is the voltage. And if we need to draw it, the current starts from where? From 70, which is here, from 70, okay, and the voltage starts from minus 20, because it's plus 20, it's minus 20 here. Okay, you can try to solve another example here, 14.4, about the inductor. Let us go about example about the capacitor. The voltage across 100 microfarad, which is the capacitance, capacitor, is provided below. What is the sinusoidal expression for the current? Sketch the V and I curves. Okay, V equal 30 sine 400t. Now we have the voltage, okay, not the current. Before in the inductor, it's given the current. If you remember here, they give us the current and need to find the voltage. Now here opposite, but does not mean. Maybe give you the current and ask you about the voltage, or give you the voltage and ask you about the current. Don't memorize the answer. Try to understand. Try to understand that in the inductor, the current lag the voltage by 90 degrees. Always apply this concept in your answer. Okay, and the current in the capacitor lead the voltage by 90 degree. Please apply this concept in all your answer. Here XL, how to find the XC, sorry, XC1 over omega C. We have C1 microfarad and omega, which is 400, apply and you will get 2500 ohm. What about the peak for the current, which is Vm over Xc, 30 over 2500 becomes 12 milliampere. Right here, 12 milli sine 400t plus 90, because we need to find the current lead the voltage. Now the current reached the zero and then the voltage reached the zero. This means the current lead the voltage by 90 degree. Okay, try to solve 14.6. Let us take some part from 14.7. For the following pairs of the voltage and current, determine whether the element involved in the capacitor and inductor is a capacitor, an inductor, or resistor. Determine the value of C, L, or R if sufficient data are provided. This means it's given voltage and the current, and the question need to decide, is this voltage and the current applied in the resistor or inductor or capacitor? Okay, and if we find the elements, type of elements, then find the XL or XC or resistor. Okay, after that we need to find the capacitance or inductance or resistor. Right. For this example, 100 sine omega t plus 40, 20 sine omega t plus 40, all of them sine and sine start from 40. This mean resistor, because in phase, all start in the same point. See here, so since V and I are in phase, the element is a resistor. Okay, and R equal peak of the voltage divided by peak of the current, 100/25. Okay, go P 1000 sine 377t plus 10, I equal 5 sine 377t minus 80. طيب, what's the shift between them? It is 90 degree. But we need to know who is the other or lag. Plus 10, this means minus 10. The curve of the voltage starts from minus 10 and the curve of the current starts from 80. This means the voltage lead the current. Which element the voltage lead the current? Capacitor or the inductor? Inductor. Okay. The inductor, the voltage lead the current, or you can say the current lag the voltage. Okay, see here, since V leads I by 90 degrees, the element is the inductor, and we can find XL, which is 1000 divided by 5, which is 200. Try to solve the other C and D. Be careful, D, it is cosine. You need to convert it to sine, then you can decide. Now we'll go to section 14.4, which is about the average power and power factor. Here, if you have this waves, okay, here in instant power, we can say the power here 0 and increase until we reach the maximum. Okay, and decrease until reach 0, and so on, like here maximum 32, and the point of 0 volt it becomes 0, and back to maximum 32. Okay, what about if we need to find the average power for this? If we have current and voltage, like here, we have the current 4 ampere and the voltage 8 ampere. To find the power, we multiply the voltage by current, voltage by current, voltage by current, voltage by current. 0 by 0, 0. For example, 1 by 2, 2. Okay, and until 4 by 8, it becomes 32. What about the part of minus? Minus by minus, it becomes positive. This means all the power delivered to the elements of the average, it will be positive. Okay, the average power, because this we need to find the average power, we don't need the instantaneous power. Right. If we need to find any average, we need to add them and divide by 2. Here, if we have peak Vm multiplied by the peak Im, which because voltage and current, to find the power, and then divide by 2 to find the average, and we know that Vm, which is the peak, if we need to write it by RMS value, it will become root 2, like last lecture we said the peak equal root 2 multiplied by RMS, and the current peak root 2 multiplied by RMS current. Root 2 multiplied by root 2, it becomes 2, 2 with 2 cancelled, VRMS multiplied by RMS. This is the formula for the average power. If we need to find the average power, direct multiply RMS by RMS, you will get the average power. Here, if we need to apply the formula voltage by sinusoidal expression multiply by current sinusoidal expression, you will multiply them, okay, and apply mathematical identity, okay. You will end the proof, you don't need it, but you will end if you go through this proof, you will end by power equal this two part, okay. First part fixed value and the second part variable, okay, because we have here t, the other no t, only substitute. If you are substitute the numbers, you will get the number. This term referred to as the average power if we say average power or real power, okay. Sorry, for this two part, this fixed we say, okay, and this because it is twice mathematically, twice frequency in this term, if you apply any number you will get zero, always this will be zero, okay, mathematically. This means the average power will be this number only, Vm Im divided by 2 cosine theta v minus theta I, which is this. See this point? The magnitude of the average power delivered in the is independent of whether V leads I or I leads V. Do not relate it to the leads or lag. Okay, the average power. Right. We say Vm V equal Vm Im divided by 2 cosine theta, and theta, we know that theta, it is theta v minus theta I, is theta v minus theta I, okay. We can say Vm divided by root 2 Im divided by root 2, which is equal RMS value. This means V RMS I RMS cosine theta is the formula for the real power or active power from now to, okay. Voltage multiplied by current multiplied by cosine theta, you will get power average. طيب. Let us apply this for the resistor and inductor and capacitor. What is the shift between theta v and theta I in the resistor? It is zero. Why? Because the theta v equal always theta I in the resistor, because in phase. It is in phase. طيب. This means cosine zero, if you substitute the theta 0, cosine theta equal 1. This means here 1, you don't need to write it. This means the power equal Vrms multiply Irms. Or you can apply the other form of formula, V square Rms over R I square Rms multiplied by R. Okay. What about the inductor? The shift between them, theta v minus theta I, it is 90 or minus 90, okay? This means cosine 90, 0, and all the term will be 0. There is no real power in the inductor. The real power only in the resistor. The average power or power dissipated by the ideal inductor is 0 watt. Similar to the capacitor, since the shift between theta v theta I is 90, cosine and 90 0. Also, the average power or power dissipated by the ideal capacitor is 0 watt. Let us go through some example. Find the average power dissipated by in the network whose input current and voltage the following. Okay, it is a resistor since the angle 40 and 40, and we know that to find the average power, peak multiplied by peak divided by 2. Okay, this means 5 by 10 divided by 2, it will be 25. If you need to find a resistor V peak over I peak to become 2, you can apply the other form of power, V square RMS divided by R, I square RMS multiplied by R. You will get the same answer. Any formula, you will get the same answer. Let us go another example. Determine the average power delivered to the network having the following input voltage and current. 100 sine omega t plus 40, I equal 20 sine omega t plus 70. We need to find the shift between 40 and 70, which is 30. Okay, to find cosine 30, and this peak by peak divided by 2. 100 by 20 divided by 2 cosine 30, it will become 866. Similar to this formula, minus 70 minus 50, it becomes 20. Okay, cosine 20 multiplied by peak divided by 2 is the answer. Last part in this chapter, we'll talk about power factor. The power factor, which is the cosine theta, and we know that cosine theta, what's theta? Is theta v minus theta I. The power is 0 if cosine theta, the power cosine theta equals 0. Okay, the power is 0. If the cosine theta equal 1, the power delivered is the maximum. Okay, because the cosine theta 0, it will substitute by in this formula. If it is 0, the real power 0, similar to capacitor inductor, pure capacitor, pure inductor, this case. And this cosine equal 1, this case the pure resistor. What about the if the cosine between 0 and 1? This means our circuit combination between resistor inductor or resistor capacitor or resistor inductor capacitor. Okay, you will find the power factor between 0 and 1. Power factor FP equal cosine theta. From this formula, you can write another form of cosine theta, which is equal here B over V RMS multiplied by I RMS. This is another form. See here, the terms leading and lagging are often written in the conjunction with the power factor. They are defined by the current through the load. If the currents lead the voltage, always our reference is the current. Okay, if the current leads voltage, we will say the power factor leading. Okay, power factor leading power factor. If the current lag the voltage, this means the power factor lagging, called lagging. يعني always when you write power factor, for example, zero point 0.5, zero point 0.6, 0.4, you need to write direct it is leading or lagging. I will understand from leading or lagging that if you said leading, this means the current lead the voltage. If you say the power factor lagging, this means the current lag the voltage. Okay? Our reference is the current here, always in the power factor. See here, the capacitor network have the leading power factor, inductive network have a lagging power factor. If you go this example, determine the power factor of the following loads and indicate whether they are leading or lagging. 14.32, this is 14.32. We have an angle for the current 40 and angle 20. How to find the difference between them? 40 minus 20 becomes 60 cosine 60.5. How to decide lead or lag? You will see who the current lead or lag the voltage. The current starts from minus 40, the voltage starts from 20. This means the current lead the voltage. We will write leading. Okay. Here 14.33, it is 80 degree for the voltage and 30 degree in the current. This means the current start from minus 30 and the voltage from minus 80. This means the current lag the voltage, it's become lagging. What about this picture? It's written fixed, the RMS 5, and RMS voltage 20. Nothing written else. This means the load is the resistor. We can find it direct. P 100 watt divided by 20 multiplied by 5, 100 over 101. And if we not found the power factor 1, this means the load is resistor. Cosine theta equal 1, this means the theta equals 0. When the angle equals 0, if the load resistor and the angle there is no in phase. If it is in phase, this means the angle will be 0 between the current and voltage, and this comes in only in the resistor. By this will end by, for from chapter 14, and for next lecture we'll start series circuits in chapter 15 inshallah.